Good morning. I am Dr. Pankaj Kumar, Associate Professor in Medicine. Today I will be covering a topic which is very common but very important and sometimes can be really vexing. Approach to a case of anemia, a common problem. Now, first thing first is that what is the definition of anemia? Anemia, according to WHO, is a condition in which the hemoglobin is less than 11 gram per deciliter in children aged less than 5 years at sea level. That is one group. In pregnant women also, if the hemoglobin is less than 11 gram per deciliter at sea level, is the next group. In non-pregnant females, a hemoglobin less than 12 gram per deciliter at sea level. And in men, a hemoglobin concentration less than 13 gram per deciliter at sea level constitute anemia. To understand anemia, we must understand the process of erythropoiesis. Erythropoiesis is the formation of RBCs. If we look at the bone marrow, it is amazing to note that bone marrow can produce in a single day a cell population of 100 billion, which can be written as 10 raised to the power 11. Now, basically all these cells, which constitutes erythrocyte and other cells also, they are formed from a stem cells, which are a pool of stem cells, which themselves are in tens of thousands. From this figure, such a huge amount can be generated. Now, the stem cells, initially they have a power to differentiate into any cell. So, afterwards they become committed to one type of cell line, which we will see in the next slide. The stem cell has two properties, the power of self-renewal and the power of differentiation. So, initially self-renewal, it forms more stem cells, and later on the stem cells are committed to produce a particular type of cells. In this diagram, as we can see, the process, it starts as a pluripotent stem cell, which can differentiate into either a common myeloid precursor or into a common lymphoid precursor. From the common myeloid precursor, we have various lines, like the erythrocytes, they develop from the myeloid precursor. We can have platelets, which also develop from the common myeloid precursor. We can have granulocytes, which are again from the common myeloid precursor. There are three types of granulocytes: the eosinophils, the basophils and the neutrophils. And also another very important cell also comes from the common myeloid precursor, that is the monocyte. And from the common lymphoid precursor, we can have various variety of T cells. Now, as far as the hematopoiesis is concerned, hematopoiesis, it starts in the fetus at about 2 to 5 months of age. It starts producing. Initially, the hematopoiesis occurs in the liver and spleen, but later on it can start occurring in almost all the bones of the fetus. But when adulthood is reached, the hematopoiesis is restricted only to the flat bones or to the ends of the long bones. But when the need for hematopoiesis is increased, as for example in cases of hemolytic anemia, the whole marrow is recruited, and sometimes we have to revert back to liver and spleen to produce the various population of cells, RBCs. Erythropoiesis undergoes various stages. Initially, the cell is having a nucleus, and this nucleus is large, and the cytoplasm is rather bluish in color. This is called the pronormoblastic stage. Later on, it goes into the normoblastic stage, and after a certain period of time, the cell, the developing red blood cell of the normoblast, it loses the nucleus and certain organelles, and it becomes what is called a reticulocyte. It is called a reticulocyte because basically it has got very few nuclear remnants, no nucleus, and these remnants, they stain as a reticular pattern with supravital stains. That's why it is called a reticulocyte. The total life of a reticulocyte is around 4 days, out of which 3 days are spent in the marrow and rest 1 day is spent in the blood, in the peripheral blood. Later, the reticulocyte matures into a RBC which survives for 120 days. This point we have already covered. The erythropoiesis is regulated by a cytokine which is a glycoprotein which is called erythropoietin or abbreviated as EPO. This starts producing more RBCs and this is responds to hypoxia. So if there are hypoxic conditions, erythropoietin is secreted more.